Okay, I just wanted to give you some notes about the 6.1 homework, just to make sure we were all on the same page. So for instance, on problem number 1, when you go to sketch that, you've got your y equals x squared, you've got your y equals 4x, so that'll have a positive slope. It'll be coming through like that. And they're talking about the area here in between. And so you would want to make sure you knew what those points of intersection were. So you would want to set those equal to one another. And then we would factor. Oops, sorry, that wouldn't be squared. And x equals 0 and x equals 4 are your points of intersection. So of course that's the point 0, 0. And then this point up here is the point 4, 16. And so when you go to figure out what the area is, you've got your area equal to the integral from 0 to 4, because I want you to realize that you would be thinking about, are you going to go, along the x, or are you going to go along the y? And really, you could do either one here. If you go along the x, you're thinking your top function is this 4x, and your bottom function is the x squared, right? Because this would be, if I drew my vertical line, that would be my top function, and this one would be my bottom function. And so this would be 4x minus x squared dx. If you were going to do the problem where you wanted to use y integration, you've got that same situation here. And then I'm just going to draw, sorry, this would have been 16 and 0. And this time, your line would have gone this way. And it would have been right function minus left function. And so the area using y integration would have been the integral from 0 to 16, because that's your y values. And your function, since this is going to be in terms of y, you would have had to solve for x here. So this would have been the square root of y, plus or minus, and you would have used the positive one. And this one would have been y over 4. And so the square root of y minus y over 4 would have been your integration if you wanted to do y integration. And y integration, you would have thought of your little, rectangle. I mean, we call it like a rectangle. You'll know why later. But, and then like the width of it is along the y, and so that's your delta y. That's like the width of it, because really you're just adding up all these, rectangles, infinitely many rectangles from 0 to 16. And the width of all of them is delta y, and delta y becomes dy. And along here, you've got all these rectangles that you're adding up from 0 to 4, and the width of each one is delta x, and your delta x becomes dx. So it's like you're adding up all these length times width, length times width, length times width, where this would be your length and this would be your width. This would be your length and this would be your width, okay, of those rectangles. So either way, I'm of course leaning towards this solution, okay? I just wanted to show you how you could have done it that other way. And now I'm going to go down to problem number 4, and I just wanted to talk about that for a minute. If you were going to sketch this, you've got your x equals 2 minus y squared. So this is going to be going this way. And then you've got this one is x equals y squared minus 4, and that one is going this way. And so the area that they're talking about is going to be this area. And you can see that if you integrated it using x, so again, think about this as a rectangle, and the width of your rectangle is delta x here. But do you see how it goes from one function and then all the way to the same function? So, and then once you get here, it's that other function. But, you know, it's not going from like one of them to the other. So I do not think you should use x integration for this one. I would not recommend that you use x integration. I would recommend that you use y integration, because when you draw your, representative rectangles here for y integration, of course, this would be your delta y, because you're imagining that you're adding up all of these rectangles, right, to get your area. It's going to go, your right function is going to be your x equals 2 minus y squared, and your left function is going to be your x equals y squared minus 4. And so for this one, if you found the area integration, you would need to know what your points of intersection are. So you do have to find these 2 points of intersection. And if you set those functions equal to one another, set your y squared minus 4 equal to your 2 minus y squared, because it's x equals x, right? And so then you would have your adding y squared to both sides, and then subtracting 2, I guess. And then you could factor your 2 out, and you would see that y equals plus or minus the square root of 3 is going to be the y. So this would be negative square root of 3 down here on the y, and this would be positive square root of 3 up there. These are y values. So you're talking about your y integration here from negative square root of 3 to positive square root of 3. Right function, 2 minus y squared, minus your left function, y squared minus 4 dy. Okay, so this one I definitely would have used y integration on that one. I do have one other problem that I want to talk to you about, and it's at the very end of your homework. It's problem number 12 here. It does not tell you enough about this problem to know what region they're talking about. So if I sketch my 12 minus x squared, okay, you saw that one first, and then I just sketched my y equals negative x, and now let's sketch my y equals 4x. It does not tell you which region it is talking about. So what I mean by that is, are they talking about this region over here? Because they just gave you these functions, and then they didn't, they just said, hey, find that area. Are they talking about that, or are they talking about this one over here? Okay, because both of those regions could be possible regions that they're asking you to find the area of. Well, I actually I found this area. I'm going to call it A, and when I looked at the key, they found that area. Okay, and the way your book gets around it is like for A, if this same problem was coming out of your calculus book, it would have given you the region bounded on the upper left by y equals 4x, the lower left by y equals negative x, and the right by y equals 12 minus x squared. That's how they would have explained your region. And if they were talking about region B, they would have said the region bounded above by y equals 12 minus x squared, below left by y equals negative x, and below right by y equals 4x. Okay? So, when you're doing this problem, I mean, I would love it if you did both of them, just to see, but your answer for A, you should get 64 thirds units cubed. Sorry, squared. I just did your next lesson, so I'm saying cubed. And the other one was 215 over 6 units squared. Okay? So I'm sure you guys are going to have problems that you want to ask me to work. If you could email me, and then I could, walk you through it, and post it, that would probably be the easiest. But anyway, don't forget to pay attention to, if you were doing A, look how you would be from 4x to negative x here, but then once you've crossed this point of intersection here, whatever that x value is, if I draw a representative rectangle here, it's going to be this other function, 12 minus x squared minus negative x. Top minus bottom changes. So this you're going to have to use two integrals. You'll need two integrals for A. Now, will you need two integrals for B? This one goes from 12 minus x squared to negative x, and it continues to do that up until 0, and then it starts going from 12 minus x squared to 4x. Okay, so either one of them, you're going to have to use two integrals to find that area. Okay, so it really doesn't matter which one. The only one that is, when I post the answers, the only one that the answer answer key has is this one. This is the other one. Okay, and I think that it's fair that they could have been talking about either one of those.